I put out the video for the changes that I made to the panther router I have here this morning. And I have one comment on the video asking how I lined up the cutter with the template on the back here with the pin that I have on the back of the machine here actually. And the first thing I have to show is how I, extended that center line from the table to the template holder back here. Basically what I did was I clamped the square in place in line with that line, and then I squared down from there and I marked a line directly onto the plywood on the template holder here. So to line up the cutter, it's not difficult. I did was I made this block of hardwood here that the 3/8 inch bits fits into, and then I line that up with the center line that's on the table over here. And now I've loosened the bolts that hold this thing on the back here, and I've made this piece of plywood here that has a center line marked on here as well that lines up with the template. I've drilled a hole that's 1, and it's exactly, the edge of it is exactly 1 inch away from this edge. What I did was I marked the center point for 1 3/16, which is half the thickness of the cutter, and I drilled a 3/8 inch hole over here on my drill press. And what I'm going to do now is I'm going to use that, I'm going to slip that in place, and what that'll do is it'll position that pin exactly in line with the cutter on the front. And I'm going to use a spring clamp to hold that piece in place until I tighten these bolts again on this pin holder on the back. And now with that done, I can remove these things that I used to line them up, and I'll save these just in case I need to do this again at some point in the future. Okay, at this point I want to mention that I got a little bit of flack from the manufacturer of this on doing these modifications to it. Basically, it changes the design to the point where it's no longer the same, and I can understand that, but that's the kind of thing that I do. I don't leave things as they are. I mess around. In no way, shape, or form am I saying that this modification that I've done here to this is better than the original or works better. It's just, to me, it seems less complex. That's all. That's the only reason why I did. And I'm a tinkerer. I like to tinker with things. I like to mess around. I like to stir things up. So that's what I did. Now you're probably saying to yourself, that's all well and good, John. Now you've got it all lined up perfectly and you showed us how to do it. When are you going to use that machine to make something? And that's actually the next part, or the second part of this video. I want to talk about my philosophy for joinery in general and for, say, mortise and tenon in particular. Okay, then I have here a box. This is a simple box that I made, I don't know, 8 years ago or more. It goes in my downdraft sanding table, which is no longer a downdraft sanding table, but it does have all these screws in there still, and it's very valuable for that. And these particular ones here are what I'm calling the bins, and they hold the individual screw sizes that I use the most. Up on top are 1 inch, right below it, which would be this one, our 1.25 inches. And as you can see, I'm running out of those, so I have to buy more. And the construction of these boxes are typical for me when I go to build something like this. Now, even though this is a workshop project and has been in continuous use for the past 8 years, opening and closing, taking it out, putting it on the table saw workbench here to take screws out of it. It often gets knocked over on the floor because I've picked up those screws a number of times, and it's still around to tell the tale today, even though it is just a box made with simple butt joints that are glued, and then I drove in, I think these are 1.25 inch 18 gauge brads to hold it basically until the glue dried. So that's as strong as this box needs to be, in my opinion. It really doesn't need to be any stronger for that purpose. And that's the that's the thrust of everything I do. I try not to make things stronger than they absolutely need to be, mainly to save time and material and time, because it takes a lot more time to make things stronger. Now, you look at this box, this is simple enough. If I wanted to make it a little bit stronger, I could add, hold on, I could add cleats to the corner on the inside here. And what I would use is solid wood, either cut square like this or on an angle so it doesn't jut out into the material. And I would have that go from the top right down to the bottom. And basically I would just glue that in there solidly. But that only works if the material that you're using to build your box with is plywood. And I will always go for plywood when it comes to building something like this rather than using solid wood. Solid wood moves with seasonal changes. It expands and contracts. Plywood doesn't do that. So that's the big advantage. You can take that cleat and you can glue that right into the corner there solidly, and it won't come out because the wood doesn't expand and contract and break it loose. So you can do that, make it substantially stronger. Like I say, it's not needed for this box, for this purpose, but in case you do need it, say the box is bigger, like if you've got a bigger drawer and you're putting car parts in there or something really heavy, then you would want something stronger. So here's another box that I made that's even stronger. It is even stronger than the box if I put cleats in the corners. And this one is put together with box joints on the sides. And even the bottom is rabbited into a slot that goes around the bottom. So that adds some glue surface and it also adds some strength there to it as well. And for all purposes you would need a box this size for, a box joint is way stronger than you'll ever need. And the only reason why I did it here was to demonstrate my box joint jig. So it was basically for looks here. That's the reason why I made this joint, and that's about the only reason why I would use this joint for this type of construction. Here's another example of something that's built with just simple butt joints that are glued and pinned together. It's this drawer that's in my cabinet down there. There are how many of these? 12. There are 12 of these. And quite a lot of them have as much weight as this one has, and even more so. And these have suffered no damage over the time I've been using these in that cabinet down there, even for this heavy purpose. And as you can see, the bottom is just OSB, 1/4 inch thick. And this grid work that's in here is basically just glued in to separate it out into compartments. Again, I just use plywood to build those drawers with. But the thing about using plywood, like I say, it doesn't expand, it doesn't contract. Therefore, you're free to glue it wherever you want to. And that's especially important on the front of the drawer. In the traditional drawer construction, you'll have the front that is attached to the subfront, and the subfront is usually attached to the sides with typically dovetails. That was the way they were done on the side. And then the bottom of the drawer was only there to keep things from falling out of the drawer through the bottom. The bottom of the drawer didn't add any structural strength other than some racking strength to the drawer itself. Whereas if you build a drawer completely from plywood, you can solidly glue that bottom panel in to the sides, to the back, and to the front. And that way you're actually quadrupling the strength you'll have in that attachment to the front. You won't need those fancy dovetails to hold this joint together over here, because you also have all of this surface area down here that's also taking that pulling load. And of course, there'll be a number of people that think that that type of philosophy or that type of approach to woodworking in general or building things in general is shoddy or sloppy or lazy. However, I talked about this before in another video, except it was on my scrap bin channel. I'll put a link in the description if I can find it, if I can figure out which one it is. And I talked about making money from building things and selling it. And that's a good lesson for a lot of people. That will really lower your standards if you want to make something and still make money from it. You cannot spend days on end figuring out joints and getting them put together and waiting for the glue up to happen, only to find that they're 1/8 of an inch too short, your drawers don't fit, and then you have to redo the whole thing. No, you have to do it quicker than that, but it has to be just as strong and just as reliable. And that's possible today with the fasteners that we have. These screws that people often put down are almost as strong and certainly as dependable as a mortise and tenon joint, and they take a fraction of the time to lay out and assemble. Traditional mortise and tenon has its place, don't get me wrong. If I'm going to be building a piece of high-end furniture, I'm going to be using mortise and tenon, or I'm going to be using dowels, or I'm going to be using floating tenons, or some other means like that. I'm going to avoid using screws. But not every project needs that type of joinery, because that type of joinery typically increases the amount of time it takes to do the project, and it also increases your chances for a critical error, especially when you're working with materials that cost money. So that about sums it up, my philosophy for building things. Like I said, the strength is important in some places, and other places it's just for show, like this box right here, or it might be for to demonstrate something, like my box joint jig, like I did here. But for the most part, you can get away with, and it's not about getting away, by the way. It's not about doing shoddy workmanship. It's about, allocating your time where it's most important. You don't want to be spending days on end making a single joint if you don't have to. If your objective, of course, is to build a project and not to spend time just working on the project.
Hey, John, need a ride?